All right, 2.2a. My function is y equals 7, and I need to take a derivative of it. Well, y equals something's a horizontal line, true? So what's my slope? Because a derivative is a slope. So what's my derivative? 0. So the way I would write it was dy dx is equal to 0. If I get f of x is equal to 0, the derivative of 0 is 0. So we say f prime is 0. If s of t is equal to a number, a -3 number, again, I get y equals a -3. That's a horizontal line. So how would I write my derivative, though? No, it's s of t, so it would be s prime of t is equal to 0. And then y is equal to a number again. Well, the derivative dy dx or y prime would be equal to 0. So any derivative of a number, a constant, is 0. All right. All right. Let's keep moving. Guys ready to be mad at me? Cool. Here we go. So here's what's called the power rule. When I derive something to a certain power, I have x to a power of what we're going to call n. The way you take a derivative is you bring down the n and then you subtract 1. That's it. So here we go. Just like what we did yesterday. Renee did this beautifully, by the way. It was beautiful. F of x is equal to x cubed plus x squared. I'm going to take a derivative of it. I bring down my 3 and I subtract 1. The derivative of x squared, I'm going to bring down my 2 and subtract 1. All right. That's what's called the power rule. All right. So the first one I have is y equals x. Y equals x. So this is the same thing as saying y equals x to the power of 1, right? So how would I notate a derivative of y? This would be dy dx, because I'm taking a derivative of y with respect to x. Now, the way we do it with the power rule is we bring down our 1, and then I subtract 1 from the power. So now I have x to the power of 0. Well, what is x to the power of 0? 1. So now I have 1 times 1, which is 1. So dy dx is equal to 1. Now, what's actually happening behind the scenes that you guys have already done, that hopefully things start making sense. Y equals x is a line like this, is it not? True? What's the slope of y equals x? Every single place. 1. Okay, cool. Let's keep moving. So now I have f of x is equal to x cubed. So now when I take a derivative, f prime would give me, bring down my 3, and now I subtract 1, so now I have 3x squared. Is it a little quicker? Okay. All right, let's look at this next one. I have g of x is equal to the cube root of x. Now, this would honestly suck using definition derivative. But let's change the way it looks. Before we take a derivative, I would rewrite this as x to the power of 1/3. Now, when I show I'm taking a derivative, I would say g prime of x. So then what gets to be brought out front? A 1/3. And now it's x to the what power? Subtract 1 from -2/3. Lovely. And then this is my childhood, so let's rewrite it. So now I'd have 1 over 3x to the power of 2/3. And now I'm done. All right. All right, let's look at this next one. I got y equals 2 over x to the power of 3. Now, before you do anything here, I would rewrite this how would I rewrite this? This would be 2x to the power of what? -3. All right. So now when I show I'm taking a derivative, I would end up with dy dx. My -3 would come to play with my 2 to give me what? -6. And then I'd have x to the power of -4. And then we would rewrite this. So then that would rewrite to -6 over x to the power of 4. All right? So now we're going to write an equation of a tangent line to the graph of f of x equals x squared when x equals -2. But if I need an equation of a tangent line, what do I need? A slope and a point. I need a slope and a point and a slope. All right? So do I have either one right now? Yeah. No. So this is where notation comes into a lot, okay? When I start grading your papers, I'm going to grade like AP will grade. So I'm looking for specific things. So the first thing we're going to do is we're going to find the point. So how do I show that I'm finding the point? All I do is substitute in. So now I have f of -2. So f of -2 is what? 4. So that shows that you found the point. Does that make sense? All right, now we're going to find its slope. Well, what the heck is a slope? A derivative. A derivative. That's what I'm looking for. A derivative. So what's my derivative? F prime of x is equal to 2x. So I found f prime. Now I want to evaluate f prime at what? -2. So now I find f prime at -2, which is -4. So my slope of my tangent is -4 at -2. So now I write an equation of my tangent line. So now I have y equals my slope of -4 times x what? +2, and then +4. And there is my equation of my tangent line. All right. Pretty good? All right, cool. We're moving. So here we go. Here we go. You can just play along with this, or you can write it with me. I don't care. All right, but sometimes we like to do what's called a constant multiple. I will bring out a constant multiple a lot. All right, it just makes it easier to work with, or just like rewriting things. So if I have y equals 2 over x, I don't want to work with it as y equals 2 over x. How would I rewrite that before I work with it? I would say y equals 2 times x to the power of what? -1. That's how I would write it. I would say 2 to the power x to the -1. So now when I take a derivative of that, I bring down my -1 to be with 2 to give me what? -2. So now I have -2 and then x to the power of -2. And then I would rewrite it as -2 over x squared. All right. On part B, what would I bring out front? What's my constant multiple I could bring out front? 4/5. All right. So I would rewrite that as 4/5 t squared. All right. And so when I take a derivative of that, what would I bring out front? The 2. The 2 plays with the 4/5 to give you what? 8/5. And then you subtract 1 from the power, so it would be 8/5 t. All right. All right, on part C, I have 2 square root x, but I wouldn't keep it like that. How would I rewrite that? 2x to the 1/2 power, exactly. And so then I would bring out my 1/2 to play with my 2 to give me 1, and then x to the power of what? We subtract 1. What's 1/2 minus 1? -1/2. And then I would put it to the basement. All right? All right, I know subtracting 1, that's crazy. All right, so part D, how would I rewrite part D? 1/2 times x to the what? Negative 2/3. All right, it's on the bottom. All right, and then how would I take a derivative of that? Multiply by negative 2/3. So I'd multiply negative 2/3, and then I'd subtract 1, and so then I'd have x to the what? We subtract 1. Negative 5/3. Thank you. All right, and then we would rewrite it. All right, on this one, what would I bring out front? I would rewrite this negative 3x over 2 thing. Negative 3/2 x, exactly. So I'd rewrite that as negative 3/2 x. And so what's my derivative of negative 3/2 x? Negative 3/2. All right. All right, so this is what I just want to show you, just to rewrite things before we work with them. All right, pretty good? Here we go. So we're going to take derivatives of these polynomials. And so they're called sum and difference rules, but really just take the derivative of each one, each part of that. All right. Now, who wants to do this definition derivative style? Anybody? No. Yeah, me either. All right. It might take a little while. So let's do it quickly with our power rule. So the way we'd notate the derivative of f would be f prime. So what's my derivative of x cubed? 3x squared. Minus, what's the derivative of 4x? Just 4. And then what's the derivative of 5? 0. It goes to 0. So I'm done. There's my derivative. Pretty good? Awesome. All right, let's look at this next one. G of x is equal to negative x to the 4th over 2 plus 3x cubed minus 2x. How do I notate taking a derivative of g of x? That would be g prime of x. Very good. All right. So when I'm taking a derivative of negative x to the 4th over 2, what comes out front? Okay, so you wanted to rewrite that first. That's fine. All right, so I'd say negative 1/2 x to the 4th. Is that what you wanted to rewrite? Cool, let's do it there. All right, so then what would we bring out front when we take a derivative? 4. So 4 plays with negative 1/2 to give me what? Negative 2. And then x to the power of 3. And then plus, what's the derivative of 3x cubed? 9x squared. And then minus 2. And we're done. Pretty good? All right, who likes the power rule? Yeah, me too. All right, now we're going to take derivatives of sine and cosine. Now we're going to take the derivatives of sine and cosine. So what's the derivative right there? What's the slope right there? 1. Love that. How about right here at pi over 2? What's the slope right there at pi over 2? 0. How about right here at pi? What's the slope there at pi? Awesome. How about right here? Awesome. So if I connect the little dots, it would look something like that. So what do we know? What's the derivative of sine x? Exactly. No. No, I'm not going with that. So right now you know sine is y and cosine is x. True? Beautiful. Love that. Then sine is opposite over hypotenuse, whatever ratio that is. And then cosine is adjacent over hypotenuse, whatever ratio that is. But truly, what's their relationship? The derivative of sine is cosine. So the slope of sine is what? Cosine. That's pretty nifty. All right, let's keep moving. So now we have cosine x. Now we have cosine x going on. What's my derivative right there of cosine?
0.
Okay. How about at pi over 2? What's my derivative? Negative 1. How about at pi? What's my derivative at pi? Okay. How about 3 pi over 2? 1. So if I connect them, it would be like that. So if f of x is equal to cosine x, what's f prime? No. It's negative sine x. Exactly. It flipped over the x-axis. So the derivative of cosine is negative sine. All right. What's the derivative of sine? Cosine. The derivative of cosine is negative sine. And when we get to more of these, it will make even more sense. All right. Pretty cool? All right. Fantastic. I'd like you to write these out. I know it looks like a lot. However, note card.